So, good morning. My name is Rantu. I'm from Data Science Department. So, today we're going to learn about bubble sort. So, bubble sort is a sorting problem. Now, what is a sorting problem is, say we are given a set of numbers like 7, 5, 3, 2. Now, the numbers are not in any order. It's neither in increasing order nor in decreasing order. So problem of sorting says that if we have to arrange the numbers either in increasing order, maybe like 2, 3, 5, 7, or in decreasing order like 7, 5, 3, 2. So the problem is sorting. So we have to arrange the number either in increasing order or in decreasing order. Now the technique used here is called bubble sort. So what is the technique used in bubble sort? Say there are four numbers 4, 3, 2, 1. Now we want to sort the numbers. In bubble sort, what we do? We put the largest number in the last position in one scan of the array. And how do we do it in bubble sort is we'll compare the first two elements. Whichever is the largest element, we'll push to the second position. So out of 4 and 3, 4 is greater than 3, so I'll push 4 here. Next, the numbers are 2 and 1. Similarly, I'll compare 4 with 2. Now 4 is greater than 2, so we'll swap the numbers 2 and 4. Next, 4 and 1. Now between 4 and 1, 4 is greater, so we'll swap the numbers again. So it will be 3, 2, 1, 4. Now after first pass, we have the largest element in the last location. So last location element is fixed. So this is sorted. This element is in sorted position. Now we have to think about the remaining elements. So here we have 3 more elements. So what we have to do here for 3, 2, 1, 4. Now first again I have to compare 3 with 2. If I compare 3 with 2, 3 is greater than 2. So I'll swap the numbers 2 and 3. It will become 2, 3, 1 and 4. Next we have to compare 1 with 3 with 1. 3 is again greater than 1. So you have to swap the numbers. Right. Now 4 is already sorted in the previous pass. So we do not need to compare 3 with 4. We'll limit our comparison till this point. So after this pass, 3 is also sorted. So similarly in the next pass, what we'll do, we'll compare 2 with 1. 2 is greater than 1. So we'll swap the numbers 1, 2, 3, 4. So after this, we have sorted the position of 4, sorted the position of placed, put the element 3 in its correct position and put element 2 in its correct position. Now automatically 1 will be in its correct position. So we have elements 1, 2, 3, 4 in sorted order. Now see if we place these elements inside the array. So what will happen? How to write the algorithm of this? So this is the technique and how to write the algorithm. So there are 4 elements 0, 1, 2, 3. So initially what we are doing, we are comparing if a of 0 means first element is greater than a of 1, then we are swapping a of 0 with a of 1. Next we are comparing if a of 1 is greater than a of 2, then what we are doing, we are swapping a of 1 with a of 2. Next we are comparing if a of 2 is greater than a of 3, then we are swapping a of 2 with a of 3. So this way we'll have the largest element in the location 3. Okay. Now for second largest element, what we'll do, we'll compare if a of 0 is greater than a of 1, we'll swap a of 0 with a of 1. Next, if a of 1 is greater than a of 2, we'll swap a of 1 with A of 2. And for the last element, last pair of element, what we are doing, if A of 0 is greater than A of 1, then swap A of 0 with A of 1. Okay. Now how to write the algorithm from this technique? You see. So in first pass, what we are doing? We are comparing A of 0 with A of 1. We are comparing A of 0 with A of 1, and whichever is the largest, if A of 0 is greater than A of 1, then we are swapping A of 0 with A of 1. Next, we are comparing A of 1 with A of 2. Next, we are comparing A of 2 with A of 3. This is for first pass. Then for second pass, what we are doing, we are comparing A of 0 with A of 1 and A of 1 with A of 2. A of 0 with A of 1 and then A of 1 with A of 2. Right. For third pass, what we are doing, we are comparing A of 0 with A of 1. Now we need to write the algorithm. We have understood the technique. We have written if the elements are present in an array, then how we are applying the technique in an array of a fixed size element that we have done. Now using these, we have to write the algorithm. So if I try to write this inside a for, if I try to do this inside a using a for loop, then what will be that? I'll start for, this starts with 0, right? So I'll start with say j equal to 0. Now the condition we'll write later, say j plus plus. What we are doing, if A of 0 is greater than A of 1. So if I write A of j, if A of j is greater than A of j plus 1. So j is 0, so A of 0, j is 0, j 0 plus 1 is A of 1. So if A of 0 is greater than A of 1, when the value of j is 0. Right? Now what will be the condition here? Okay, we'll check with different values of j. Initially when the value of j is 0, then what are the elements we are comparing? A of 0 with A of j plus 1. Value of j is 0 is, so it is A of 1. So we have done this comparison, A of 0 with A of 1. Next, value of j is 1. Then what are the elements we are comparing? A of j means A of 1, A of j plus 1 means A of 2. Next, value of j is 2. So if value of j is 2, then what are the elements we are comparing? A of 2 with A of 3. So you have compared A0, A1, A1, A2, next A2, A3. Okay. So the value of j will be equal to 2, right? It cannot be go beyond 2. So if I take the value of j is 3, so what are the elements you are comparing then? A of 3 with A of 4. But there is no element with A of 4, right? So we should not go beyond 2. So I can write it as j less than 3, right? We can write j less than 3. So using this for loop, we have done this first pass, right? But there are many passes. And if we see that in first pass, the last element we are accessing is A of 3. In second pass, the last element we are accessing is A of 2. In the next pass, where the last element we are accessing is A of 1. So for first pass, it will go for j equal to 0 to j equal to 2. For next pass, it should go for j equal to 0 to j equal to 1. So for that, we'll use a outer for loop. Now outer for loop here signifies how many passes. Now if there are 4 elements in the array, and if I correctly put 3 elements in correct position, then automatically the 4th element will be in its correct position, right? So if there are 4 elements, I need to scan, find correct place for 3 elements. If there are 4 elements in total, then I need to find correct position for 3 elements, right? So I can write it as I equal to 0, I less than 4, I plus plus, right? Now if I just write j less than 3, then this loop will run for always compare a0, a1, a2, a1, a2, a2, a3, right? But see, when the value of I is 0, when the value of I is 0 means we are doing the first pass. First pass we want a0 to a3, right? a0 to a3. So j will be, last value of j will be 2, right? Last value of j will be 2, and the elements compared will be, last two pairs will be a of j plus 1, means a of 2 and a of 2 plus 1, 3, right? When the value of I is 1, that means we have already done one pass. That means we have already put the third element in its correct position, right? Now this time I do not want to compare a of 2 with a of 3. I want to compare with a of 1 with a of 2. I want to compare a of 1 with a of 2. Now if I want to compare a of 1 with a of 2, what will be the last value of j? I cannot put here 2, right? If I write 2, it will become 3. So I should write here 1. J equal to 1 means j plus 1 should be equal to 2. Now see, this loop should be decremented by 1, right? So when the value of I is 1, so I can write here minus I. If I write minus I, when I is equal to 0, it will be j less than 3. J less than 3 is j equal to 2. Last values will be a of 2 with a of 3. When the value of I is 1, it will be j less than 3 minus 1. J less than 2. J less than 2 will be j equal to 1. Last value of j will be 1. So the last value of j will be 1. The last pair will be a of j with a of j plus 1. So a of 1 with a of 2, right? So this, on the last value, what will be the next value of I? See, next value of I should be 2. So it should not be 4, it should be less than 3. See, that's why you should not write this directly. I is 2, right? If the value of I is 2, j, last value of j will become j less than 3 minus I, means 3 minus 2. 3 minus 2 is 1, right? J less than 1 means last value of j will be 0, right? The condition will be j less than 3 minus I. So value of I is 2. So j will be less than 1. J is initialized to 0. So the only valid value of j will be 0. So if the value of j is 0, so what are the elements compared? A of j. A of j means a of 0 with a of j plus 1. A of 1. Right? So it should be I less than 3, I plus plus, right? Now we have taken here numbers as 3, right? But generally whenever we write algorithm, we need to write in terms of variable input. Here the size number of elements are 4. So that's why we are taking 3, means 1 less, right? So if the number of elements are n, then we have to take it as n minus 1. So what can I do here? Instead of writing 3, I can write here n minus 1. Instead of writing 3 minus I, we can write here n minus 1 minus